Hi, we're going to pick up our conversation at the last and final component of the memory system, which is long-term memory. You will find on the website at least one interactive activity. I know there's one having to deal with short-term memory, kind of a self-learning, self-testing interactive activity. And so anytime those are available, I suggest that you use them because they're very helpful. But in terms of long-term, we're going to go on to long-term activity, long-term memory. It's this process here. And I want to point out that you're looking at the movement of information from working memory to long-term memory. If you look at the processes involved, it says encoding. That's a big part. So you've got to encode as information moves from working to long-term memory. There's an encoding in long-term memory, and it's different than how it was encoded in working memory. And we know working memory is transient. I mean, my goodness, it fades right away if you don't do something with it. So you've got to be thinking about something, putting ideas together, and then moving it into long-term memory. And as you move it in a meaningful way, you're encoding it meaningfully. Hopefully you can retrieve it, as you see here, retrieve it meaningfully. And doing this over and over again might be a lot like rehearsal. The best kind of rehearsal, as is talked about in your textbook, is elaborative rehearsal, meaning you think about something in many different ways. So every time you think about it, slightly differently, you're elaborating on it. You're expanding upon it. You're increasing the connections to that information. You see, there's some rehearsal that just is keeping it in working memory. Like when I say the phone number as I move from the phone book to the telephone to call the pizza place. But if I'm putting information meaningful into long-term memory, I want to encode that information in a way I can retrieve it in multiple ways. As with all the other memory stores, I have a slide here that gives you some of the major characteristics. First, information is encoded from short-term memory, and it's encoded by meaningfulness. What does that look like? I'm just going to tell you its meaningfulness. The slides I'm going to show you are words, but really they're not words. They're not language. It's meaning of the language. Now, the third bullet point here says there are a variety of theories about how these encoded ideas are stored. Since you're not going to be doing research in cognitive psychology, you probably don't need to know all of these, but they do exist. People spend their whole life looking at these models. We're going to talk about the propositional network model. That's the most popular. It has something to do with how ideas are associated. Also, you see the word schemas and scripts. That's also a popular way to think about it. That was my dissertation. I like schema theory. It's not quite the same thing as Piaget's schemas, but close enough. Well, maybe not close enough, but close enough for us. I want to point out that the size of long-term memory, it says here, is unlimited. And so even though students frequently say to me, Dr. Miller, I can't learn anymore. My brain is full. Stop now. And certainly I feel like that sometimes. That's not true. We have, I don't know, virtually unlimited capacity for learning. And this is the most wonderful thing, I think, ever. Now, also we have to do that well so we can retrieve the information. And how long is that memory in there? Well, it's fairly permanent, but retrieval can fail. And when you can't recall something, it could be retrieval has failed, or maybe really you didn't get the information encoded in a way sufficient to be recalled. our long-term memory systems, we have two different kinds of, and actually these are physiological structures. There's a different structure or network, physiological network, for procedural knowledge than there is for declarative knowledge or fact knowledge. Procedural knowledge, eye blinks. Procedural knowledge, how to ride a bicycle. People have damage to the frontal lobe. Sometimes they have maintain great procedural knowledge, but have lost their memory for who they are, or lost their memory about things, or so that's declarative knowledge. I just also want to point out that when we talk about information, some information can be explicit. That means it's conscious to me, I can explain it, I know what it is. Other information may be kind of below my level of conscious awareness. By living in a culture and engaging in certain activities, I've developed an implicit knowledge about things. And if you ask me direct questions, I might not be able to answer that directly. I don't want to say it's unconscious, but it's kind of like unconscious information that I've gathered about my environment and my world and me. As teachers, we deal a whole lot in explicit information, but as we interact with others, we're conveying implicit information. How do we treat each other with respect and dignity? How should teachers behave? If you're working in the medical profession, how should doctors interact with patients, interact with nurses, and so forth? There's a lot of implicit information that we also convey, and we may not even be aware that we're doing that. A lot of the ideas that we have about long-term memory, and we're only going to really look at information processing theories or a network model, really, is that these ideas are connected. So and you'll see this, the nodes are connected by pathways, and the distance between the nodes represent closer similarities to these concepts. And let's take a look at one of those. Here we go. This is a network model. I can't remember even where a generic one where I found this. And it's a very simple one. A bird is an animal. That's a complete idea. Can be judged true or false. That is what a proposition is. A bird has wings. A bird has feathers. A mammal can nurse their young. So you see that ideas are connected, and the closer the ideas are connected to the node, the closer the association is. So this is a hypothesized one. And here's a second one, very similar, kind of more hierarchical in some way. And a very specific one developed by Collins and Quillian, two well-known cognitive researchers. And they test whether this is the right model or not. That's what these people do. That's their life. That's their career. That's what they do. And you can see that when we think about animals, actually, we think more quickly that a bird is an animal compared to a fish is an animal. Now, both are animals, but this longer arrow here, this longer node or pathway, suggests that if we did a reaction time test between is a bird an animal, hit the button, is a fish an animal, hit the button, that people will be faster acknowledging a bird is an animal than a fish is an animal. That's the notion of these distance between these concepts. And two big ideas about long-term memory. The first is we need to encode information in a way that facilitates retrieval. And so if we go back just to even this graph here, this model, we need to think about how we're presenting our information so that students can retrieve it. This is organized. Information is organized. It's not all over the place. It's not in a file cabinet either. It's not alphabetical. It's by meaning. And so when we talk with students, we need to talk in meaningfulness, in ways that are meaningful. I organized this discussion we had based on 3 components of memory, the kind of the standard model of memory: sensory, working memory, and long-term memory. So I give you an organized structure, and I give you characteristics under each one. And so right there, you can make a chart, you can make a graph, you can organize the information in some way that's meaningful, that you can retrieve it. What are the duration? How is information encoded in each sensory unit? How is information? What's the duration of the information? What's the capacity of each store? So there's a way you could organize that and study that, by maybe making a chart, something like that. You may have seen these in terms of concept maps. Teachers ask students to draw a concept map of something that they've been studying. That's to help them organize and connect ideas together. The second big idea about long-term memory is that memory is reconstructed. This is one of the most fun things to study as a cognitive psychologist. We do not store and retrieve information verbatim and recall it verbatim like a snapshot. It just is not. That's not how it works. And so if I go back here, what I'm saying is that this is not something verbatim that you're going to retrieve. Sometimes students try to retrieve things verbatim that I may have said in class, and maybe if they write it down well, they can, well, you said this. Well, yeah, but they have to understand what that means. And usually by that point they don't. If they've memorized it, they don't understand it. You've got to put things in your own words, because it turns out that over the long run, and I can give you the research on this, it's really, really clear that we remember the gist of things. We remember things kind of on the fly. When I say, tell me about a canary, it's not that you're going to go to the sentence here and tell me in a kind of a memorized format the sentences that you've learned about a canary. You're going to think about it and say, well, a canary is a kind of a bird, and it flies and has feathers, and the feathers are yellow. And one of the unique characteristics about canaries is it's a songbird. I know that because on the back of the songbird food container for a food container for birds, the songbirds have a certain kind of food you need to give them, and that's what I typically buy, so I know it's a songbird. We remember the gist of things. We don't tend to remember verbatim. And the longer we go across time, the more and more details fade away until what we remember is the gist of something. Now, the reason I remember a lot more detail about the things I'm talking about in this class is that I talk about them every semester, over again, over and over. So I remember some details. I remember Peterson and Peterson, 1959. Not most people are not going to remember that, but they will remember the gist. Hey, there were a couple of guys that did some research, maybe a man and a woman, I don't remember. And they did research and they found out that short-term memory without rehearsal lasts about 20 seconds or less. That's probably how people remember this. They don't remember details about the study. Okay, we're going to do a follow-up, one final module or conversation on memory, and I'll be right back with you. Thanks a lot. Bye now.